So we are continuing on with regression. All right, we did this example. What I want to show off is how to create that residual plot. So the first thing we need to do is calculate all the predicted values. Call that y hat. And it's just plugging it into the equation that we got last time. Right, where your x is just going to be the hours studied column, or the x column, right? Your explanatory variable. Residual is just your actual value minus the predicted value. No. Predicted minus actual. Right. Negative residual means it's an underestimate. Positive residual means it's an overestimate. So here's what I want to do. X, residuals, and then just a scatter plot. Except I think they mixed it up. That's not what I want. So I'll double click. Right click, select data. Don't want that on the horizontal. Move that on the vertical. No, that's right. I'm sorry. The explanatory is the horizontal. That's right. Let's call this residual plot exams. Where's hours? Right, and that would be the residual plot. Remember, the linear approximation is appropriate if the residual plot shows no discernible pattern. There's no discernible pattern here. So we can conclude that, yes, that linear approximation is appropriate. Depth of a diver, maximum dive time. We're studied. We're given the x, the y. Also given all of our information, r squared, and y. We're just going to be asked to interpret that and use that. So the first thing they want is interpret the slope. What is the slope? What's the slope of our line? Negative 1.3, right? Now for the interpretation. The response variable here is the maximum dive time. The explanatory is the depth. They don't give us units. So for each unit increase in depth, the maximum dive time decreases by about 1.3 units. And that's what a negative slope means, right? It's decreasing. Positive slope means it's increasing, right? Predict maximum dive at a depth of 85. Would, using this model to predict our maximum dive time at a depth of 85 units make sense? Think back to Thursday. When should we be making predictions? Using the least squares in mind. So would it make sense, first of all, to do it? Why? So what about the depth data 5? Why would it make sense to make a prediction using this least squares line? We said something about when you should use it to make a prediction. Two terms, interpolation and extrapolation. What was extrapolation? What happened?
Extrapolation is outside of the domain.
When you're trying to make a prediction from a data point that falls outside the range, right? Is 85 in our range? What was the range of values for x? Is 85 in there? Then it would make sense to make this prediction, right? 85 falls in our range. This is interpolation. Which does make sense. Right? The prediction is meaningful, is what that means. And then it's actually just plug it into the least squares line, right? Which is 139. I'm going to write it this way to represent that we're predicting the response when the explanatory is 85. 20.5, whatever the units of time they're using happens to be. C, predict maximum dive time at a depth of 110. Would that make sense to do? This one would be extrapolation, right? So the result isn't meaningful. We really shouldn't predict it. I'm going to anyway, but I'm going to label it as extrapolation. Yeah. Gave you -4. Clearly doesn't make any sense. Okay, here we go. We have a data set for the explanatory variable. It's 1 through 10. And they gave us the set of residuals. Doesn't specify it here, but I'm going to assume in the proper order. They want us to just examine the residual plot and determine if a linear relation is appropriate. So we entered our data. Remember, you want your x to be the explanatory, you want your y to be the residual, and that's just a scatter plot from that. Does a linear relation seem appropriate here? Why? What happened?
It doesn't show a continuing.
Well, remember, this isn't the scatter plot for the data. This is the residual plot. So remember the rule with the residual plot. Linear relation is appropriate if there's no discernible pattern.
Equals to what?
If there's no discernible pattern. There's a pattern here, isn't there? No. So regression analysis of teacher pay on spending per student found that regression line with the R squared, right? So we just put the data into Excel and had it generate the line in R squared for us. First, give and interpret R. So R squared, first of all, I want that as a decimal. R squared, coefficient of determination, which is just the square of the coefficient of regression, or the coefficient of correlation. But what happens? Take a square root. So for example, square root of x squared, how does that simplify? X. What if x is negative 2? What's negative 2 squared? No, negative 2 squared, not square root of negative 2. Negative 2 squared. Four, right? What's the square root of 4? What's the square root of 4? Not 4 squared, square root of 4. Is 2 equal to negative 2? Then that can't equal x. Because I said x was negative 2. the absolute value of x. Right? When you take the square root, you get plus or minus, right? By definition, square root always gives you a positive, but the variable itself could be either positive or negative. R can be positive or negative, right? Well, which one is it? Because you only have one value. So is R going to be positive or negative in this case? Well, to do that, look at the slope. So R is positive. All right, slope of the line is positive. That means a positive correlation, possibly, which means your coefficient of correlation should also be positive. So I'll just put a plus sign out there to indicate we're taking the positive. If that was minus 1.318 instead, you take the negative square root. Again, I'm just going to double check my calculations. Oops, that's not right. About 0.8375. The interpretation. It's a moderately strong positive linear correlation. And the closer to 1 R is, the stronger the linear correlation appears to be. Positive, right? The closer to -1 it is, the stronger the negative linear correlation appears to be. Generally speaking, if it's 0.5, I would say that's not only weak, that's very weak. So B was to predict pay at $12,500 per student. So we do have a problem here in that they're asking us to predict the 12,500, but we don't know what the range is. That comes in part C, which I can't assume. So I have no idea if this is interpolation or extrapolation. I have no idea if this is going to be meaningful in any way. I'm just going to note that. And I'll just plug it in. 22074 plus 1.318 minus 12,500. again, obviously make sure you know how to use your calculator and you can get these values. $38,549. And so when the spending per student is 12,500, we expect the teacher pay to be 38,549. That is not much more than minimum wage. If we use what most states use now, 15 an hour. Oh, actually, I'm sorry. That's actually below minimum wage. Teachers only work 9 out of 10 months, not 12. So I don't know. I guess depending on the year, either 8 weeks less or 9 weeks less. Divided by, let's say 4 weeks. Divide that by, oh no, it's still slightly more. That'd be about 22 an hour. If you assume. It's terrible. Now, if data ranged 8,097 to 22,366, should you predict pay at $24,000 spent per student? It would fall outside of our range, so we shouldn't predict it. Wouldn't be meaningful. That is again called extrapolation. No idea what happened here. I do not. Okay. Let's see that now. So we use this data set. That's 398 rows. So 398 data points. And we're going to do those things, right? We want to report the fitted line, give and interpret R and R squared, interpret slope. This is actually import. G. So we want miles per gallon and weight. So I'll just hide all these. We want, if I go back, okay, they tell what I was going to say. What do you think the explanatory variable would be versus the response? Okay, so that's response variable MPG. Explanatory is weight. That means I want weight to be the first column. So all we have to do is highlight it, cut it right here, and start cut cells. What happened? I messed everything up. Let's do this for them. Insert scatter plot. Select data. If I do it this way, it's going to give me X and Y, which I don't want. X and a colon separately. This lights. Okay, so you can't see it. Because the screen share is so weird. Oh my. That is interesting. No, except it still did MPGs first. Why did it do that? Select data, switch from column. Oh, of course. No, there it is, edit, okay. The X values. Weight. Y values. And usually. Okay. Doesn't look much better. But. And why is everything connected with lines? Layout. Don't want lines. Those are all dots. You have to use the right chart, right? No, I didn't. Apparently. Now it's the right chart. Okay, that was somewhat better. Now the question is, should we adjust? Should we adjust the axes? Maybe go 1,000 to 6,000. Doesn't hurt to do it in this case, because you're not really going to mislead anyone. It's just zooming in, right? The pattern is still the same. Yeah, I think that looks better. So that's what I'm going to do. What does it want us to do? Report the fitted line. Okay, so that's that. Now I just have to add a trend line. So solid line, I can use a gradient line. I'll just do solid line. I think it's going to connect multiple pieces though, so no line. Used to do it this way. Trend line, linear. I can probably make that stand out a bit. Let's change the colors of the dots. Let me change the colors of the dots. That's annoying. Thought I could. Ah, fill. Okay. That's only if I want out like that. Oh, the orange kind of sticks out better. And this I can be like 10 actually. Change the outline. There we go. It's black. Now it stands out. Now remember, if we double click that line, display equation, display R squared. Let's just move that. And call this MPG versus so there's the fitted line. Give and interpret R and R squared. I already knew what R squared was. Percent variability in miles per gallon and remember, that's what R squared is. So we can explain about 69.18% of the variability in the miles per gallon by the weight. Here, square root that's the square root of R squared. Should that be negative or positive? Slope is what? Negative or positive slope? What is it? Slope is positive? Slope is negative. So our R is going to be negative. Makes sense, right? You would expect a negative relationship between weight and miles per gallon. The more the car weighs, the less miles you'd expect per gallon. We also wanted to interpret slope in context. I'm assuming it weights in pounds. Each additional pound weight. And so each additional pound we would approximate as a decrease of 0.0077 miles per gallon. That's what the slope is in this case. Predict miles per gallon for 2,500 and 4,000. What's that, S7? You can just use Excel to do it. What was the other one? 4,000? Here I don't have to say that. You take that, so just drag and drop it. What is the observed weight range, I think is the next part. Can we predict it for 5,200? Well, it looks like this is the largest data point here. And I have no idea what that is. So what I can do range just do the minimum of weight. To the maximum. There's the range, right? Could we predict 5,200 pounds? And it would be extrapolation. So it would really be meaningful. And examine the residual plot. No boy. That's going to be annoying. Residual. It's going to equal predicted that's giving me at MPG. So I'm going to do A2 minus, oh no, sorry. Parentheses, I want the predicted first. So it's negative 0.0077 times A2 plus 46317, then minus A2. I have to try to drop it. It did it for me. I think it's because it created this part of the table already. But now I get to my x stays the same, my y becomes the residual. Oh dear. Why did you do that? There's the residual plot. Would a linear approximation be appropriate here? So. It's probably a good first approximation, but I would argue I see a pattern in the residuals. Is it a perfect pattern? No. But is it discernible? Yes. So if I say be careful, linear may not be a good fit for this data. Questions on the linear regression? Y'all are going to be relying on technology for this topic, relying on it very heavily. And my preferred is Excel. My preferred is far, but that's too advanced. At this point, you should be able to finish up the group project. We start something fun next. We get to start probabilities. So that's Thursday, right? Thursday's going to be probabilities. Just the basics of probability, basically just introducing probability theory. What is a probability, and we'll calculate some real basic probabilities. But next week is even better. Next week is the 7th week of the semester. I need some midterms next week. Specifically, the midterm is next Thursday. Next Tuesday will just be review. I've already generated a set of review questions to go over in class with the midterm. So we're doing nothing new at all next week. Thursday will be the basic of probability theory. Then next Tuesday is review questions. Next Thursday is the midterm itself, which will be in class. I do have a worksheet here for you if you want to work on it, or if you want to finish up that group project, whatever, but the next 15 minutes is dedicated to the group work. Go ahead and get your groups.